All right, we're live. Hey, Matthew, how are
Hello,
you?
Billy. I'm good, thanks. How you doing?
I'm doing pretty good. So, yeah, really been looking forward to this.
Me too.
Two-factor authentication and security is always really important. So, with that, let's just go ahead and get it started. I will go ahead and get it started with our. Ooh,
Ooh.
1 second. I. Okay.
All
Sorry
good.
about that. I had my the YouTube live stream in the background, and that was causing some weird feedback.
Oh.
I made a mistake that I told you not to make. All right, there we go. Sorry about that. And now let me share my
Cool.
screen. Oh no. Hold on 1 second. Oh no. This is annoying. So I forgot. This I just got a new work computer because I recently changed jobs, and that's what I'm running this from. And let's see, try capturing screen. And I think it's one of those really annoying things where I had to restart my computer to show off. But it doesn't matter too much. To everyone watching this, sorry about that. I'll go and go through the Java deck and I'll post it in the screen, but I can just kind of read off all of it. It's not super or some interesting information, but I think we can share it verbally instead of visually. So for our sponsors, thank you. And again, at always that will be VMware and Tanzu for supporting and paying the meetup fees. And while we're obviously still virtual, hopefully, at some point, maybe this year, possibly, or sometime, we'll be able to start meeting again. And hopefully we'll be able to still do it YRC late, but we'll still go ahead and thank them because they were our meetup location before this. And of course, we want to thank Twilio for having Matthew join us today. So that is really awesome. It's been a long time since Matthew and last met in person, but again, hopefully at some point in the not too distant future, we'll be able to see each other again.
Yeah.
So for the Java news of the month, by far the biggest piece of news that just actually happened this week is the release of Java 16. Which is really awesome. And within Java 16, the biggest change or biggest addition is records. And again, I realize you can't see the slides I'm looking at right now, but on the slide deck, I included some links to it. And so obviously, probably like the easiest thing to grok with records is the developer experience. It's going to make it much easier to create those simple data carrier classes that we work with all the time. But there's much more significant changes under the covers with it, particularly around serialization. Serialization is one of those really sticky things in Java. If you kind of actually see like all the underlying problems with it, and so to that, I do include a link to a description, a really great article that kind of covers some of the big things that records tries to solve when it comes to serialization. So definitely check that out if you're going to kind of understand some of the bigger implications of records.
I read a good post about serialization this week. Was that yours? Was it Brian Vermeer?
Was it maybe? It may have been Brian Vermeer. It wasn't me. This one is from like our Inside Java. It's a simple serialization with records. I think I know what you're talking about with Brian. All right, Brian though.
Brian from Sneak about the security problems.
Yeah. There's a lot of security issues with serialization. My former colleague Steve Poole also had a really great presentation where I'm like, oh, I had no idea all these security issues with serialization. Another big addition is pattern matching for instance of. So it's so annoying where you have to do like instance of value and instance of string. If it's an instance of string, then put like a cast and assign it to this variable. There's a much more simpler syntax that can handle all that, so you don't have to have like 4 lines of code or 3 or 4 lines of code to kind of cover that. It can all be done in about 2 lines, and it's just much more straightforward. And then lastly is JPackage. So obviously, the big thing about Java is write once, run error. Where you build it, you get either a jar, war, or ear, and you have to run it on a JVM. JPackage, it allows you to create an artifact that includes the JVM itself, so it's installable per system. So that way, instead of having users both have to install and run your application as your jar, war, or whatever, and also having to download and install JVM, it can all just come in one single package. And then the last thing is there's Java Mission Control, and also I include a link to that. So our Java Mission Control 8, which was released concurrently with Java 16, and I include a link to both JPackage and also Java Mission Control to kind of cover both what they are or what's new in Java Mission Control 8. I kind of forgot to include releases for other major updates. I don't know, maybe I just missed them. I don't know if there are yet. I do think Spring Boot 2.5 will come with support for Java 16. I did see a tweet about that. I did see they had Spring Boot 2.4.4 was released, but I didn't see it had support for Java 16 unless I missed that. So I know a lot of Spring users are in this group. Cool. The last one is actually I was really good this time. I got our next meetup posted. So Red Hat, they're going to be doing a really great workshop. There's going to be several speakers from Red Hat, and they're going to do a big workshop, kind of like this one, on Java, or not Java, on Quarkus. And that's going to be April 22nd and 5:15. So that should be a really awesome meetup, and I hope you all can join us there. Actually, I think Steve Poole, who I just mentioned, should be there. Several other Java champions will be there as well. So definitely check it out if you can. It's already in a meetup, and I'll also get that posted and tweeted out as well later today. So one last thing, and we going to get this out there, is as mentioned in the meetup maker, that this is also a bit of a workshop presentation. And here is a link. You should see it now in the live chat, GitHub link to Matthew's GitHub page. So definitely check that out once we get into the workshop portion. And I'll kind of go ahead and leave it to you so you have plenty of time to present, and we have plenty of time for the workshop.
Awesome. Thanks, Billy.
All right.
See ya. Oh, okay. So hi, everyone. Yeah, so like Billy mentioned, there's going to be a workshop part this evening. But first of all, a talk. So the link that Billy's posted will be useful later on. And if you want to get cracking, like having a look at that README whilst I'm talking, or if you want to get the thing downloaded, by all means, go ahead. So hello, anyway, everybody. My name is Matthew Gilliard. I am a developer evangelist for Twilio. I'm based in the UK, where it is currently day 2 of hay fever season, so I'm a little bit like fuzzy, but I'm pretty sure we can get through a fun evening talking about two-factor authentication. So 2FA, 2Furious. Let me do a transition. There you go. All right. So you'll see my contact details. Maximum Gilliard on Twitter, mgilliard@twilio.com. If you get interested in the workshop and you have to leave early, or if you have any questions anytime, please feel free to get in touch with me. That's absolutely fine. Otherwise, Billy's monitoring the chat. I've got it open as well. We'll see any questions that come in. So feel free to ask anything. Now I'm going to have to start, I'm afraid, the talk now. Well, I'm very happy to be starting the talk, but I'm afraid that I'm going to have to start with some bad news, which is that there are people around who are up to no good. I'm talking about this guy, right? You might think, from the collar down, he's a fairly respectable looking businessman. And perhaps it's like, I don't know actually whether it's particularly cold at the moment in KC, but if you end up having to wear a balaclava at work just to keep warm, just be aware that it's going to make you look like this guy, like a hacker, right? He's up to no good. This guy smashing credentials out of a website with a hammer, obviously up to no good as well. There are hackers and bad actors around. This lady is pretty good. She's managed to get hold of a laptop and start doing some hacking even whilst in prison. And she's obviously pretty cross that someone's snuck up behind her. So if you're up to no good, prison uniform or balaclava, and that will let everyone know. But it's not always that obvious. Here's another headshot of a person. And this person is not up to no good. This person is a journalist named of Matt Honan. And Matt Honan used to write for Wired, and he was the victim of a pretty sort of complex set of attacks against various online accounts that he owns, like personal accounts, I mean. And in exchange for agreeing not to press charges against the hacker, he got a really very detailed description, which he wrote up on Wired. You can go and read it. It's really interesting, but I'm going to summarize it now, and then we'll come back and look at a few aspects of it through the lens of what we learn about 2FA later on in the talk. So let's start. Matt Honan. He has a personal website, a custom domain name, and he put his Gmail address on it so that people could get in touch with him. That seems like a reasonable thing to do. I do that. I'm sure a lot of you do that as well. It's not like doesn't seem like an obvious kind of entry point for a sophisticated hack. But people decided to pick on him for whatever reason. We'll get to the reason later, I suppose. But people did decide to pick on him, and they found his Gmail address, Matt's Gmail address, on his personal domain. And they went to Gmail and they triggered the password reset flow. And Gmail said, okay, we've sent an email to your backup email address. And for privacy, we're not going to show that email address on the screen. We're going to redact it. So there's no possible way that anyone could know who isn't you where that email is going to go. And so they showed this on the screen. And I think it's pretty obvious, actually, that is matthonan@me.com. The fact that it's me.com as well becomes relevant in a bit, but the redaction is, it's not doing the job it's supposed to do there. Next up, these hackers, they did a whois lookup on the domain name of his personal site. Whois is a tool that you can query DNS, so you can find out information about who and when, who registered it, a domain name, and when it was registered. My vanity domain is Gilliard.lol, and this is the whois result for it, or like a section of the whois result. Hope you can see my mouse cursor. I think you can. So there's domain name at the top, registered with Gandhi, the registrar. There's all details, admin stuff. And down the bottom, there's a bunch of stuff here that's redacted for privacy. And this is like my name, where I live, city, postal code, country with GB, right? That's not redacted. But in Matt's case, this wasn't redacted, and it's redacted by default with Gandhi and probably these days with most registrars, but that's not always been the case, and it doesn't have to be redacted. So these people, by doing the whois lookup, had found Matt's actual home address. You might be able to find that other ways these days without using whois. But anyway, they had it now. So what's next? Call up Amazon and add a credit card to his account. It's like thinking emoji. That's a bit of a weird thing to do. Because what are they going to do with that? Well, it's probably a stolen credit card. It's probably not the hacker's real credit card. So these are back in the day when you could actually phone Amazon and talk to a human. I don't suppose that's really the case anymore. But they were unable to answer the various security questions, but they managed to convince Amazon that they were talking to the real Matt Honan because they knew his email address and they knew his billing address. So they could add a credit card to his account. This seems like a fairly low risk thing to be allowed to do. There's a bit of social engineering to bypass the standard kind of security questions. So blah, 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 please add this credit card, read out the number, it gets added to the account, hang up. What next? Call Amazon again, this time asking for a password reset. And again, they couldn't answer the security questions related to the account, but they knew his email address, they knew his billing address, and they knew the last 4 digits of one of the credit cards on his account, which is a slightly stronger burden of proof, but it's obviously still fraudulent. And anyway, they were able to gain access to Matt's Amazon account through this technique. Brilliant, Amazon account. What are they going to do with that? Because this isn't where it ends. In fact, this is where it accelerates. And through Matt's kind of investigative journalism, we get timestamps on things now. At 4:33 p.m. on the day in question, they called Apple to reset his Apple password. Now, again, they couldn't answer the standard security questions, mother's maiden name or what have you, with this, but they were able to convince Apple that they were the real Matt Honan because they knew his email address, his billing address, and they knew the last 4 digits of his credit card. But they didn't know the last 4 digits of Matt's actual credit card, did they? Well, yes, they did, because you can get that by being logged into Amazon. This is a screenshot of the expired cards in my Amazon account, also a screenshot of my gift card balance, just in case. And the point is that once they had access to his Amazon account, they could see the last 4 digits of every one of Matt's cards, including his real card, right? And this is the very information that Amazon considers like okay to show. Apple considers it like proof positive that you are who say you are. So each of these companies had security policies. There's a bit of social engineering, but they also had slightly mismatched security policies, which the cracks in between them are part of what enabled this hack. Okay, so the Apple ID password reset took 17 minutes. So that's the timestamp there. And then they were able to go and reset the Gmail account password, because you can log into a me.com inbox using Apple ID. So once they were there, they were able to re-trigger the Gmail account reset flow, intercept the email in the me.com inbox, reset the Gmail account password. And this was a little bit quicker than 17 minutes. Excuse me. A few minutes after that, they wiped his iPhone. And this is actually the first Matt knew what was going on, right? Because his iPhone just turns off. A bit weird. Right? I don't know, consumer devices fail. Maybe you don't think like it's annoying, but you can fix it. 1 minute after that, they reset his Twitter password by being able to access his Google inbox. They were, that was the backup for that. Then they wiped his MacBook and deleted his Google account. And this is a significant problem for Matt right now, because he's got no computer, no phone, no Google account. He can see perhaps on friends' computers that his Twitter account is compromised, because the end game for these hackers was to post some kind of offensive language to Twitter and take credit for having done so, because Matt's Twitter handle is @MAT, and they thought, oh, that's a nice one, let's play with him. In the end, most of this was restored. The thing that Matt lost permanently was some of the things on his MacBook, some family photos, which he is a very kind of patient and mature attitude kind of person, so I should have backed them up. It's kind of interesting to note that at no point did the hackers actually know any of Matt's actual passwords, right? They were able to do password resets, and then they knew the new passwords. And none of these accounts had 2FA. We'll think later, once we've got a bit more to grips with 2FA, about what would have happened if they had. But anyway, let's talk about passwords for a moment. This guy wants to know your passwords. I've been told by Billy that there is a delay between me speaking and you seeing it. So the interactive chat bit might be a bit weird, but we can try it in a minute. We'll try it in a minute. What advice do you hear frequently about passwords? Use strong passwords. Don't reuse passwords. And therefore, realistically, unless you've got an enormous memory and a very... Thank you. I did see that in the chat. Unless you've got an enormous memory, you're going to have to use a password manager to do so. You can maybe see up here, I've got LastPass. I've recently started paying for LastPass, and I am glad to do so. It's a vital part of how I keep things safe online. There are alternatives though. Password managers, there are a few of them. I strongly recommend using one. I have something like 200 or 300 accounts in LastPass. There's no way I would be able to remember that many different passwords, especially if they're all strong and complicated. The reason why we don't use the same password on multiple accounts, right, is because when services get hacked and big leaks occur of username password combos, they get dumped online. And if you've reused the same password, then perhaps you know that service A has been compromised, but you have to go through and think, oh, where else have I used that password, right? And there is a service that actually collates all of these leaked auth detail dumps and makes an API that's available, and you can use it. And this service is called Have I Been Pwned? And I'm like in my 40s and a little bit uncomfortable with the word pwned, but I'll go with it. So Have I Been Pwned collates all of these leaked credentials and makes it searchable, so that you can go there and you can do it right now if you want, although perhaps wait till I finish talking. You can go there and put in your username and your password, and you can see how many times that has appeared. Or you can just put in a password and see how many times that appears in all the breach data. Have I Been Pwned has over 10 billion leaked sets of credentials in it at the moment, which is a phenomenal number, right? That's more than there are people. And it's growing. Like every time I give this talk, I have to go and add another 1 billion to the intro slide because it just keeps growing and growing and growing. They also offer an API, and this is a tweet that a friend of mine, Paul, who's a member of the Java community in the UK, talked about adding it to Co-op Digital. So he works for Cooperative Digital, which manage real, like, significantly important life services for people. We're talking like insurance, financial details, not banking, but things like store cards, a lot of important stuff. I'm not saying like that kitten pictures aren't important, but this isn't kitten pictures. This is like significantly important information. And he's added, or he and his team have taken the time to add, Have I Been Pwned integration to password validation in Cooperative Digital. So here's what he wrote on Twitter, right? We see around a quarter of people try to use a compromised password and then change to a safe one. So you've got these like restrictions here about having a strong password, but also your password must not appear in a list of hacked passwords. And you get this message, choose a different one. Right, so Paul goes on. When you reset your password, so when you have an existing account, you reset your password, you can't choose a password in the pwned password set. And when you register, so when you're creating a new account, we started by just warning so as to not impact conversion. But we've since stopped letting folk use compromised password on registration too, and it's had no identifiable impact on conversion. So this is a great move by Paul, by Cooperative Digital, and by his team to improve the security of how they manage their users' data. The users entrust them to look after it safely, and this is one of the ways that they do it. And Paul's got metrics that say, actually, this doesn't reduce user signups, making people choose unique passwords hasn't been a problem there. I skipped over a sentence in the middle, though, here. When they were just warning people, between a third and a quarter of folk chose to use a compromised password anyway, right? So between a third and a quarter. So like, yeah, 25 to 35-ish% of people ignored this warning, right? The one you have entered appears in a list of hacked passwords. So like this is borne out again and again. When we talk about password security, we can, as IT industry professionals, we can offer good advice. We can say, oh, don't reuse passwords, use strong passwords. There is a significant body of evidence that says that users of our services don't do this, right? And it is not, I think we have an ethical kind of responsibility to acknowledge that fact and not just say, you need to use strong passwords and that's the end of it, right? If you do that, you'll be fine, because we know that people won't. We're neglecting our professional responsibility if we rely on this in the face of like strong evidence that it's not reliable. And we can do better. And that may be the end of my little rant about that. For now, I'm going to lighten the mood with a quiz. Most common passwords in Have I Been Pwned. I'm going to see if this is the thing where the 30-second delay on chat trips me up, but I'm looking for the 5 most common passwords in the Have I Been Pwned data set. Feel free to stick them into chat. I'm going to have a drink, and if any have arrived, that'll be good. If not, I will just crack on. I am God. Well, let's see. I'll say, like, between them, these top 5 account for hundreds of millions of accounts that have found their way into the Have I Been Pwned data set. Hundreds of millions of accounts, okay? And so the first one, yeah, yeah, that's right. I'm seeing some answers come in, and there's some good ones here. So these people, like, I'm not going to say people are lazy, but they are just putting their finger there and going like that, right? The next password, 50% less lazy, putting their finger there and going like a little bit further. Why not, right? So these are the 2 most common passwords. The next one, it's just the same, but one row down, right? People just reaching one row further, less far up the keyboard before they do their stroke. Next up, the one we all know is going to be in here, password. Woo! And the fifth one came as a bit of a surprise to me because I actually find it rather difficult to type. I haven't tried using it as a password, but obviously I've typed it like a few times with regard to giving this talk. You have to count whilst you're typing this, and it's like 111, 111, and like a stripe across the numbers or something's much easier. Anyway, there you go. We know that these passwords and many other ones are very commonly used. We know that people reuse passwords. It is on us to do better than to say, well, that's their problem, right? This is my thesis. Second small rant over. Let's look at the way that we can do better. Two-factor authentication. So this guy's got a laptop and a hammer. I wonder if those could be two factors of authentication, perhaps not. Let's define the terms then, okay? So that we all know what I'm talking about and we've got a shared understanding of it. What even are what does factors mean, right? We have a sort of understanding that you need two things. So there are types of factors: knowledge factors, possession factors, inheritance factors. So something you know, something you have, or something you are. They're the most common. And two-factor authentication means you need information from more than one, well, two type of factor, okay? So if we look at a normal login flow, user enters their username, user enters their password. Those are two separate things, but they're both knowledge factors. So this is not two-factor authentication. We need a second factor, which is not knowledge, possession or inheritance, something you are, like biometrics or something like that. So you may be able to think of an example like, I know my PIN and I have my bank card, so I can withdraw money from the ATM. That's two-factor authentication, like classic example. So it's not like unfamiliar territory for most people, but in the context of computing, everything's a bit more confusing, right? So you might be wondering like whether it has to be knowledge and possession or inheritance. I don't think it does. I'll talk about an example later where we can get away with possession and inheritance as the two factors. And this is actually something that's very common, at least in Europe, and I guess probably in America as well, to do with banking. But for now, we'll assume a username and password as a knowledge factor, and we'll look at what the common types of second factor are. Okay, so let's crack on with it. Ooh, press both arrows at once there. SMS, this is a common type of second factor. Excuse me. It's a possession factor, and the thing that you're possessing is your phone. So you know the deal, right? You've probably actually got an account like this. When you register with a website, you put in your phone number, they send you a text, probably using Twilio, just saying. They'll send you a text, you type in the contents of that text. It doesn't really matter. It's often like a 6-digit number, but it doesn't have to be. It just has to be something difficult to guess. And that proves that you own the phone. Then when you come to log in again, they've remembered your phone number. They send you another text. You type in the contents. Again, it doesn't actually matter what it is, as long as it's difficult to guess. And that is considered proof that you are in possession of that phone. So the possession of the phone is the second factor there. I seeing some comments about SMS being bad, and yeah, pros and cons of SMS. Well, SMS is ubiquitous. Like more than half the planet has access to SMS by either a smartphone or a feature phone. It is not totally secure. Thank you about the office. It is not totally secure. There are SIM jacking where you convince the phone network that through social engineering to swap your phone with your victim's phone. There is the possibility of intercepting the radio signals between the tower and the phone and decrypting them on the fly. And this is true. I can't deny it, but I can say that it's still significantly better than not having any form of 2FA in terms of security. Those attacks tend to have to be targeted either against an individual or against a physical location. So to say that because they exist, SMS 2FA is unuseful is, I think, not true. But there are better ways of doing it. So let's crack on. HOTP and TOTP, which you'll recognize the kind of Google Authenticator app there. And in both cases, the OTP stands for one-time password. And these are the 6-digit numbers that you get from your Authenticator app that you have to type in when you log into a website. We can look at how these work right now. So they're both one-time passwords. The H is hash-based one-time password, and the T is time-based one-time password. And actually, you'll never see in the wild, or rarely see in the wild, HOTP, but it's understanding it is a useful stepping stone towards understanding TOTP, which is what you will see if you're using the Authenticator app. So let's have a quick look at how these work. There is, for HOTP, a secret string, which is generated when a user creates an account. It's generated on the server, it's stored on the server, and it's shared securely with the user. And we'll talk about how later. Deshaun, thank you for the comment about the office. The only thing wrong with it is the dog's not there. Sorry. Okay, anyway, so secret string created and shared at account registration time. There's a counter which starts at 0, and there is this concept of digits, which is just literally the number of digits you want in your code. It doesn't have to be 6. And the algorithm, I mean, I won't go into all the details, but the algorithm looks like this, right? You get your 6-digit code by implementing a hash function, a hashing function, where the arguments are the secret, which never changes, although it's different for each user, it never changes for that user, and the counter. This hashing algorithm is defined in an RFC and is going to be like every implementation of HOTP will generate the same codes from the same secrets and counters, and then we use modulo to chop off the last 6 digits, and that's what the code is here, right? And then what happens every time someone logs in, every time a code is generated, the client and the server increase their counter by 1, right? And this seems like reasonable, but you can easily imagine that there's a problem where they can get out of sync if you generate a code and don't use it to log in, or if you want to use 2 phones to share an account for some reason. It doesn't work unless you have some out-of-band way of resynchronizing the counters. But in its sort of essence, it's quite sort of simple, but the counter drift problem is difficult, right? There's no real getting around it. It will happen eventually. Maybe you can say, well, we'll generate 3 codes. We use counter -1, and counter +1. We'll generate 3 codes, and any of those will be fine, and then we'll know which. But they'll get out of sync by 2 eventually, and you've also tripled the number of possible ways that someone could guess their way in. So what if we had some kind of counter that was like just shared without any coordination between clients and servers? That's what TOTP does by using like wall clock time as the counter. And current time block here refers to the fact that this is basically an integer that increments every 30 seconds. So that's why when you look at your Authenticator app, the code cycles every 30 seconds because the current time block is changing. Time block, the algorithm's otherwise identical. So the counter is an argument here to the hash. This is also defined in an RFC. So all the different Authenticator apps, like the Microsoft one, the Okta one, the Authy one, the Google one, they all implement the same algorithm and will all generate the same codes, which means you can get away with only having 1 of them on your phone and just have all your accounts in there. Current time block ticks over every 30 seconds. My phone and my computer are in sync within like a second or so. So it kind of works. If you were worried about it perhaps not being in sync, or the fact that it might tick over during the check or between the user typing it in and pressing the button, maybe you could double the number of checks, or you could just say, like, sorry, try again, that one expired whilst you were typing it in. So that's up to you as the implementer, right? But the deal here is that this RFC defines this hashing algorithm, and based on the current time and the shared secret, which is created at account registration time, you can keep generating new codes every 30 seconds. The client will generate them. You can generate them on the server side because you know the same secret. And if when someone comes to log in, they type in a code, and you generate the same code, that proves that you have the same shared secret, which proves that they still have the phone or the device that they had when they registered. The only problem with this is the secret sharing. Well, we'll talk about that in a moment. It's secure as long as the secret is shared securely. The apps are a bit fiddly. Like, I get a little bit annoyed with it. Not as much as I get annoyed with having like an SMS inbox full of 6-digit codes, but still, like getting the phone out, typing the thing. Oh no, I've typoed it. Oh no, it's expired whilst I was doing it. I don't know. It's not that annoying really, but I didn't want to have no cons at all. But if you have other cons, please put them into chat. I'm happy with that. Now, I've talked enough and you've been very patient with me, but I want to do some coding now. So some one-time password coding. And in case you're doubting my credentials, I do own a balaclava. So that's me from a different angle. That angle, maybe. Or that angle. So, okay, let's go and do it. Let's go and do it. And we can see how, the pseudocode I showed a minute ago can look in Java code. So that's the link that Billy shared earlier. What I want to do is show you this. Right, okay. So I've got a project here, and I can share this code later. I'm using a library called JOTP. It was obviously going to be called that or OTP4J. This is the link on GitHub. I'll show you this code afterwards. But it shows you how the code looks, and it looks extremely similar to that pseudocode that I showed a moment ago. You can generate using this .otp.randombase32 the secret string. I've hard-coded it here because I want to use it in a different context in a moment, so I don't want it just changing every time I run the code. But we take it as secret. We get a counter, which is otp.time in hex. That's what the algorithm wants. And we call otp.create, passing those two things, the length of the code we want and the fact that we want TOTP. And so I'm going to run this. And you can appreciate that this section of the talk may take up to 30 seconds. 415408. 415408. Okay, so it didn't take 30 seconds. 215071. So if I've got a user who's trying to log in, I can look up their user details in my database. I know that this is the secret string because I've stored that in the database as well, next to their username and the hash of their password. You can't store a hash of this because you need to reconstitute it exactly to be able to generate the code. But yeah, if they supply a code from their authenticator app that matches the code that I'm generating here, then I can be sure that they know this secret string. So the only question, which I've been dancing around for a little while now, and I'm going to finally get to the point, is how do we share the secret? And the answer is using everyone's favorite thing, the QR code. This is commonly done with QR codes. I mean, there are other ways. So much like you can have URLs for websites which start with https://. There are URLs for OTP authentication, and the library can create you one. You pass in the secret, the number of digits you want, the fact that it's a TOTP, the name of the service, and the name of the user on that service, which is only to help the app like display it to the user so that they know which thing they're clicking on when they click on their app. So this code generates the auth URL, OTP auth://. Print that out, and then I'm using the Google Charts API to turn that into a QR code as well. So I'm going to run this code. And if you get your phones out and fire up an authenticator app and get ready to add a new account, we can do it together. You know what? I'm going to get my phone out as well in a moment. So this is the OTP auth URL. You can see it's a TOTP, the site, the user, the shared secrets in there, and then there's a bunch of other stuff which we don't need to worry about. And then this is the URL for the QR code. So I'll click on this. I wonder where it's going to open. There, okay. So this is the point where I'm going to bring up my phone. I'm going to fire up the Authy app and scan the QR code. This is my real phone. Hello. There we go. No idea why Authy has chosen that logo, but I'll save that. And I'll just leave this up for a moment so that you can scan the QR codes if that's what you want to do. If you are doing this live with me, this code will change every 30 seconds. So you'll see the same code. If there really is a 30-second delay on streaming to YouTube, then you'll see the previous code. And if you're watching this video on demand later, then you'll see something completely different. But anyone who scans this QR code has the same algorithm in the Authenticator app, and they have the same shared secret. And presumably we don't all have the same time. But if we had the same time, we'd be generating the same codes. And I can show you that back in my code, which was down here. If I go back to the previous example, and this is why I wanted to reuse the same secret in both cases, because I can now say we've got 788.286 on the right. And if I run this, 788.286, right? It's the same. It's about to expire. So it's now 049568. Run this again. 049568. So you can see like my clocks are roughly in sync enough, at least, that I could use this as a mechanism to prove that I own the phone, which provides the second factor of authentication. I'm going to hide my phone. And that is some code that during the workshop, the objective will be to add that same kind of code into a Spring Boot app that actually has web pages for user registration and login. So we'll start from an app that uses username and password only, and we'll add two-factor authentication to it using QR codes, TOTP, and Authenticator apps. There's like an optional extra on it as well, which is to use the Have I Been Pwned API to stop people, even if they're using 2FA, from using crappy passwords. I think it's a good idea. Hey, Billy.
We did get a question here.
Oh, yeah.
I'll just post it up here. And what happens if you change the date time in the machine?
Well, that's a good question. And I'm not tempted to try it on my laptop or my phone right now, because who knows what StreamYard will make of that. But these rely on having clocks in sync. And I suppose if you can convince like java.currentTime millis to return something that isn't accurate, then you'll be generating the wrong codes, because it's based on the wall clock time, the Java implementation. I mean, we can dig into time in hex and see how it works, I suppose. Oh, there you go. So if this isn't reporting accurately, then one of the inputs to the hashing function will be incorrect, and so the resulting code will be incorrect compared to what it is on the other end. If you mess with the client, then the server will have a different one. If you mess with the server, the client will have a different one. Well, in either case, they're both different. They're not the same. So the answer is you won't be able to log in. Unless, like, 1 in a million chance, I suppose, that you guess the right one. So what's important here is as well, like, this is the output of an algorithm that is defined in terms of integers and long numbers. So the fact that these are 6-digit codes really is like part of the implementation. Whereas when we were talking about SMS, it just had to be something that's difficult to guess. And a 6-digit number is difficult to guess, but it could equally just be a couple of random words. How is it handled if the machine is in a different time zone than the user? UTC. Every calculation that wants to be immune to time zones, just set the system clock to be in UTC, and then that's the same all around the world. I guess it's currently 11 p.m. UTC right now, because that's what I'm in at the moment. So, yeah. Cool.
And we got another question with time zones as well. So.
Oh, yeah. Yeah. So as long as you're going to have problems, right? Unless you use UTC on your servers, and the applications on the phone, obviously they know your local time, but they will be able to use UTC for these calculations. So when I say current time, I mean current time in UTC, which both sides of the equation needs, will be able to know. Thank you for the question, though. Good one. Right, let's go back to here. Oh, God, look at that guy. Right, okay. Let's go. That's enough about one-time passwords, although, like I said, we will come back to them when we get into the workshop part in a minute, in a few minutes. Push notifications are the other type of possession factor where the factor is your phone that are commonly used, right? And these work differently. You have a service. Let's say I'm setting up an airline called Owl Air, and I want to authenticate my clients, and I want to use push notifications for it. Now, I, as Owl Air, don't have the ability to push notifications to my users directly unless they've got the Owl Air app. But let's say I haven't been developing an app, then I have to partner with someone like Okta, like Authy, like RSA, Microsoft, who have developed an app. And when someone tries to log in to Owl Air, I will tell my partner, send them a push notification and tell me if they said yes. And so you, as the user who's trying to log in, will have to have the matching app. So you can't, like you could do with one-time passwords, coalesce them all into one app. You'll need several. That's a little bit annoying, but it's not that bad. Once you've got them installed, you just forget about them. We use Okta at Twilio. Okta sends push notifications. I can accept them or decline them from my watch. Oh, thank you, Brandon, for clarifying that. Yeah, current time millis is always in UTC, which is cool. So, where was I? Oh, yes, accepting Okta things on my phone. Yeah, that's super convenient. And like, imagine what had happened if Matt Honan had had a notification on his iPhone, like someone's trying to reset your Gmail password. Is that you? You just press no, and that's like end of very short introductory section to this to this talk. And like Matt would have saved himself. Well, I was going to say he would have saved himself a lot of bother. He didn't cause that bother. He was the victim of like a directed and unkind attack, to say the least. So he could have protected himself better, but he should have, it wasn't ultimately his fault that someone did that to him. Yeah, okay. So what about push notifications? Well, they're very, in terms of security, they're great. There's no one-time password. It's end-to-end public private key encryption between the service, like in this screenshot here, it's the RSA app, and the RSA service is sending encrypted requests, and it's just sending back a yes or a no. Sometimes they're a little bit more complicated. It's not just a yes or a no, but it also can refer to something that you could see on the screen. So like when I try and log into some accounts, it says, is this you? Yes. Okay, what number can you see on the screen? And that's like an extra level that actually would make me stop and think, because I might otherwise just be lazy and just say yeah without really thinking about it. I guess it doesn't add any kind of, well, the security it adds is in the sense of encouraging me to slow down and consider without just saying yes to everything. Okay, so secure and easy. You need a lot of apps. That's not really a big deal because you only need to install them once, and then the push notifications just appear when they appear and go away when they go away, and you don't need to really interact with the app very much. So these three are the big three 2FA in terms of logging into websites, right? And in each case, the second factor is a possession, and it's going to be very commonly a smartphone. But it is worth discussing other types of factors just out of interest. Like we talked already about having a bank card with a PIN, and that's a possession and knowledge, but there is also biometric factors. And if you're familiar with Red Dwarf, the kind of British sci-fi comedy from, I don't know when, 80s, 90s, you might maybe remember this episode, but notice that the leather jacket guy, that's not really his hand, right? He's taking advantage of someone who's unfortunately lost an arm. Anyway, this is kind of interesting because there is an example widely used in Europe, at least, of two-factor authentication where it's inherence and possession without knowledge, and it's contactless payments. So when I go to a shop and I want to buy something, I can use my bank card and I can contactlessly pay. And that is a single factor of authentication because you only need to have the card. Just tap it, it's done. And there's a limit of about $50 worth, 40 something pounds of how much I can buy with that. But if I use my phone to pay contactlessly, there is not such a limit because phones need, firstly, you need to have the phone, but you also will need to unlock the phone to be able to use it, which is either done through knowing a PIN, so knowledge factor, as well as the possession of the phone, or Face ID, or like I do with the thumbprint. So in fact, when I pay for something using contactless on my phone, I'm using 2FA with a possession and an inherence factor and no knowledge factor. So anyone who's got my phone and my thumb could, oh, I need that, could do it, right? So biometrics, I think when we talk about biometrics in terms of logging into websites, that's less common, but it is actually a very common way of 2FA in terms of like payments at point of sale. So I'm going to summarize right now just by saying, like, if you're tempted to write your own authentication kind of framework from scratch, know please that there are failure modes that are very difficult to spot, very subtle, and like devastating to the effectiveness of it. And we see this phrase, right? Friends don't let friends write auth frameworks. Lean on the hard work of people who've done it before. That's my advice. And we say the same, right, about two-factor auth frameworks. Twilio bought a company called Authy a while ago, which offers push notifications, falling back to one-time passwords, falling back to SMS. But there are lots of alternatives. Feel free to check out authy.com/whatis2fa for more. Do your own research. But I use Authy, and I could recommend it to anyone. So once we've started taking our professional responsibility seriously to look after our users' data, once we've learned about how authentication mechanisms work in the abstract, and once we've decided not to roll our own but to lean on the work of others, then we can make the web safer for our users, and we can stop people. I've actually still got my little padlock here. That must not be mine. But we can stop people like this sneaking all the user data out of our databases. So thank you for listening to the talk. We're going to move on to the workshop. These are my contact details. They'll be up. I'm saying you shouldn't create your own auth framework from scratch, but we're going to look in the workshop. Sorry, I'm referring to a comment from chat there. We're going to see in the workshop about using the work that's been done in the RFCs about one-time passwords to add a second factor of authentication to a Spring Boot app. Billy, do you have anything to say whilst I take like a couple of seconds to have a drink and switch over to that?
No, yeah, this has been a really good talk, though. I was kind of learning, like I just was like, oh, SMS would be generally fine, but I kind of forgot about like SIM card jacking to where that could be a problem to people could hack it, and then it's not quite as secure as some of the other formats.
No, but it is still better than like single-factor authentication. I think that messaging gets lost sometimes, so I'm happy to have the chance to say it again now. Thank you.
Yeah. No, I've definitely. I think for most of them, for most of like at least my important stuff, I probably should put it on everything I can. I have two-factor authentication between this and then like Rob Wench, who you may know, but he's the team leader on Spring Security. He's kind of also in our group, and he's helped convince me the errors of my security ways before.
I see someone's just put a question of YubiKeys. Mm-hmm. Yeah, YubiKey is proprietary, and they work in lots of different ways, and there's lots of different types. They do have an HOTP, which has this out-of-band resynchronization of counters. I think some of the USB keys don't have clocks in them, so they can't use time-based one-time passwords unless they're plugged in, and then they can use the computer's clock. But it's a lot of it's proprietary as well, so I don't know for sure how a lot of it works. WebAuthn is very interesting. That has a way that a website can request to a browser that there's a second factor of authentication involved, like either a hardware token or a biometric thing. Okay, look, I'm going to switch screens here, back to the coding one, but actually, oh, that didn't go very well. Crikey. Yeah, nice. Confused my browser. So for the workshop section, Nice one. For the workshop section, this is the URL that Casey Jug has posted in the chat a few times, and I'm just going to read through it. The goal of this workshop is to take an application which only has username and password auth and improve security by adding time-based one-time password, two-factor authentication, TOTP 2FA, to the user registration and the login flows. You'll need Java 8. I tested it up to Java 16 today. Happy Java 16 week, everybody. Yeah, I use IntelliJ, and you'll need Git. And the way I've structured the repository is that there are tags for each stage, and there's only like 3 stages. But if you check out just the repo, you will be at the finished stage. And if you want to work through it, then -B, start here, or there's a tag called start here. That's where my code is at the moment. There's my contact details again up here. So if you ever need to ask me anything, if you're watching this like video on demand later, or if you have to leave and you want to ask me something about it later, anytime, get in touch. Your mission is to update this app so that, yes, we said that's a moment ago. It may sound complicated, but don't worry. In total, you'll need to edit 7 files out of about the sort of 20 that are there, and add about 100 lines of code. All of the code that you'll need is given in the walkthrough if you need it. So don't feel like this is supposed to be difficult or is supposed to get you stuck. What this is supposed to be is like illustrative of where you need to intercept things in the flow to be able to add to FA. So once you've got the app cloned, you can run it from the command line, or you can run it from your IDE. And then you open your browser at localhost 8080. I need to start it running. So I'm going to kick off. I'm at the start here tag. Kick this off. Off it goes. And localhost 8080 should be up and running. Yeah. So you can register. Matthew, password, create account. Fine. Then you can log in. Matthew, password. And once you're in, you can see a personal page, which is, oh, the dog's not behind me, but you can see a picture of him. Then you can log off. And that's it. There is the challenge here is to, on the registration page, when someone creates an account, show them a QR code and then verify that they have scanned that into their app and that they are providing the right 6-digit code when they come to do log in later. The other thing that you might be interested to know is that there's an in-memory database. That means that every time you restart the app, the database will be cleared, but you can see a link here on the README to the console if you ever need to check what's gone into the database. So let's have a quick look now. The password is password. I'm not going to make you guess that, although maybe you could have done anyway. User DTO is the only table in here, and if you click on user DTO, select star from user DTO, you can see there is user 123, that was there, that's preceded. There's Matthew, that's the account I've just created. And so one of the challenges is going to be adding a new column, which is the secret, the 2FA shared secret in here. But do not worry, as I said before, when we get to how to proceed, if you're not familiar with Spring Boot, like ask me anything, read through this code walkthrough, have a look through the code, ask a friend. Don't please just sit there and get stuck, because I feel it's completely possible for everyone to get through this evening. So there is 2FA set up to the user registration flow, to the user login flow, and then optional extra credit for keen people to add calls to the Have I Been Pwned API. But in each case, when you click through, first of all, it tells you to look for things in the code to do registration, and then I've created a walkthrough for each one, which literally links to what you need to add and where you need to add it. So hopefully that is clear. So the challenge for the registration part then is add the OTP library, JOTP, change the database schema, change the user DTO to match the schema, create users shared secrets when they log in, get the OTP auth URL, and show the QR code. So there's 7 changes needed. Each one is a few lines, and each one, again, like click on finished code to see it. I suspect that may take, including actually getting the app checked out, perhaps up to 25, 30 minutes or so. I'm going to leave you all to crack on with it, and I'm going to stop talking, give my throat a rest. But if there are any questions, please do jump in. And otherwise, over to you all. So I will ask, actually, rather than giving my throat a rest, I will ask anyone who's doing this, please confirm in the chat that you're at least able to like clone the repo, get to the tag, and run the like login. Cool. Wait. What I'm saying is, authentication is fairly complicated. The failure modes are not always obvious and can be very significant in terms of their effect. If you're comfortable with that and confident, I guess you can create your own auth framework. But I would strongly recommend using another one that has been created by someone else. But now I feel like maybe you are someone who does know all that and has created your own, and it is probably excellent. I've run out of tea. I'll tell you what, if people are going along, then perhaps I'll start doing the coding slowly in the background as well.
So I'm going through it, and I think it looks like a lot. I mean, I'm only on like the second step of the first one. But like the JOTP was already uncommented in the POM, and it looks like the database stuff has already been added there as well. So I think when I initially tried to get in, it was already doing all the two-factor authentication, or it was doing all the two-factor authentication.
Did you start at the start here tag when you cloned it?
Oh, I just did the main.
Git checkout start here. And yeah, because if you just check out the main, you will be at the end.
Gotcha. Well, see, I don't read instructions ever.
That's okay. That's okay. Neither do I. So yeah. There's a tag start here, and that.
Yeah. Now I'm seeing that.
So when you like one class that will be different will be.
Yeah, I posted that in there instead. Yeah, I made a mistake. I just do git clone, whatever.
Yeah. So when you look, like the very first thing to do will be to uncomment this dependency. Which I'll do now. And generally look for like things marked to do registration. I'll tell you what I'm going to do whilst I'm here. I'm going to look for see if there's a newer version of this. Yes, there is one, but naughty. Okay, sorry. Let's use it. IntelliJ doesn't like it. Yes, it does. The internet has caught up with it. Okay, so let's bin that off. We need to use an OTP library. I like JOTP, but like I say, they all work the same, right? Because they're all implementing the same algorithm. For each user, we need to store a secret key in the database. So the database creation script is source main resources. We've got data.sql. I'm going to add a new column to user DTO. I happen to know that later on in the code, I will be creating 20 character strings, so 20 is fine. And we do need to probably modify this as well. Cool. The user DTO class should match the database schema. Add a new field and getter and setter matching the column. And I suppose Spring will be using reflection to map field names to column names, so it's important to use the same name. I called it secret here, so I'll call it secret in the code as well. User DTO to do registration. So let's do a string secret. Justin, seeing your question there in chat, these refer to the validation that's done when the user fills in the registration form. So in those cases, they do need to provide a username and password, but there will not be a secret yet. So I leave those annotations off at this point, because once we've got a user DTO, then we can create the secret for a new user. I mean, once we've got a user DTO for a new user, we can create the secret. So generate getters and setters for that, for the reflection magic to work. Don't forget, you wouldn't have to do this with records, would you? Although you probably can't use records as DTOs because they're immutable. That will not include ID because I don't care about that. There we go. It doesn't matter, you don't need to change that toString actually. So user DTO should match the database schema. Feel free to start the app and inspect the database schema. So I'll do that. Stop it, restart it. Sorry, if you think my font is ridiculously big, I agree. I just wanted to make sure it was readable on the screen. But I don't usually code like that. Right, that's started up. So cool. Yeah, it's pretty readable. So when you've done this, you will need to log in again because bouncing the server, this is an in-memory database, including the session ID. Oh, crikey. Type the word password wrong. Nice. Okay, so user DTO. Now, yeah, this user's got no secret. And if I go through, register here, Matthew, password, create account. Crikey, what have I done wrong? Oh, I've probably, well, I've only done half the instructions, right? That's probably what the problem is. Oh God, this Oh, look, yes, I said not null in the data.sql, and then I've left it null here, so it has been unable to save it. Well, that's fine. It shouldn't be null. It's just, like I said, because I've only done half the instructions. So let's stop the server, because I'm going to have to fix it before it will work again. Next thing to do, generate a secret key when a new user registered and store it in the database. And that is going to go in userservice.java. These are, I believe, like sort of standard ways of laying out a Spring Boot app. So although it looks to me like there's quite a lot of code there, hopefully it's not kind of terrifically confusing. But here we are. We're in this create new user method. We've been passed in a user DTO, which represents what they have typed in on the page. So at this point, we can check if there's already a user with that username and throw the exception if they do. Otherwise, encode the password. And the thing we need to do here before persisting to the database is user DTO.setSecret pp.base32 20. We know 20 is fine. We know that'll fit. And then save it. Let's try that. Create your account. Absolutely will. Did I just do the same thing twice in a row? Most likely. Did I leave too long for 60? Oh, that's interesting. 20 is the length, but that is actually 32 characters. So I'm going to change my data.sql. I'm just going to make this longer. Bounce the app and try again. Yeah, let's do that. Hey! Thank you for creating your account. You can now log in. And this is the page that should show me the QR code, but it doesn't yet. That's the next thing we need to add, I suppose. And then the thing after that will be actually checking that, adding a new field to that. So I'll give you another look at the dog. This is my dog called Haku. Can boop on the nose anytime. Feel free to save that picture if you need cheering up later on. He's asleep now. Anyway, sorry. Got through the first part of it without issues. Nice one. Then I will speed myself up a little bit. Why not? So where was I? We were at the point of wanting to show. Yes, generate the UI. Yeah. So we're going to, in web controller, when we're showing the thank you for registering page, web controller, whoops, wrong one. Web controller registered, this one. So when you've registered, yes. So in here, I think the way we're going to do this is by adding a new field into the model. Add attributes to, actually, just to be completely sure that I don't mess this up, I'm going to check this. Yeah, we are using model add attribute, and it's actually quite a lot of code, so I'm pleased to be copying and pasting this. But yeah, do the imports. URL encoder.encode, like I think UTF-8 should be supported, but everywhere, but add the exception. to the method signature anyway, because we've got to do something with it. It's a checked exception. So this is very similar to the code I showed when I was doing the demo in the middle of the talk, right? We're calling otp.getURL, passing in the secret, the number of digits, TOTP, the name of the app. You can change this if you want, it doesn't matter. It's just cosmetic in the Authenticator app. And the username, which again, you can change, but you might as well use their actual username. And then we use Google Chart API to create a QR code of that. And then we add the QR code URL to the model and return registered, which is a reference to registered.html in the templates folder. Again, save time, I'm going to actually copy this from here. Bit of handwritten HTML. Yoink. Okay, so now if I bounce the server, what you should see, and there's a way which we can check that everything's kind of hooked together properly. If I go, spin off that tab, if I go to register, Matthew, password, terrible, but I know. Then we're seeing a QR code. First of all, one thing I could do is, one thing I could do is like literally add it here and see that it is getting added to my Authy app. Actually not going to save it, but we know at least that it is a valid QR code for an Authy thing, for an Authenticator app. The reason I'm not going to save it is because it's going to change every time I restart the app, and I don't want to, like, I'll have to keep deleting it and re-adding it to my phone. But I will add it once we've got the login flow. I'll actually add it and use it. But what we can do is look at the image location, copy image location, and you'll see in the URL, if you squint, there is the secret there. So it starts UKAX and it ends with ZQ. And Justin, good stuff. I'm going to run this query, which will make me log in again. Let's have a look what's in there. So it's, yeah, UKAX ending with ZQ. So I'm not going to check the intermediate digits, letters, but I can say that that secret is appearing as part of this OTP auth URL as the secret that's embedded in this QR code. So I think everything's hooked together nicely. Let's go back to the home page. Still, you don't actually need the QR code to log in, right? You don't need the app to log in because nothing in the login flow is checking your 6-digit code. That is in part 2. So let me just wait a minute, have another drink. You got through part 1. Unless you're like ahead of the game. Users can still log in using just username and password. Yeah, you can just copy and paste the code. Like, the point is not that this code, I wanted you to like puzzle out exactly how to write it, but more like, you know, it's instructive about where you need to put the code, and actually, surprisingly, you don't need that much. So log in. You don't even need to copy and paste it. You know, you can just check out the finished version from GitHub. Just use that, and then you'll be able to look at my dog at any time you want. So this time we're looking for things marked with to do login, and there are 4 things to do. The code in at least the last 2 is a little bit longer, but there's only 4 things. So first one, add a field to login.html. Let's do that. So login.html, hypertext markup language. Let's copy this and paste it. And it doesn't like there are 2 things with the same ID, 2FA code. Doesn't like that because there's nothing with that ID yet. There we go. Give it that name. So we'll see how that name's used in a moment. Oh, sorry. The H2 password is password. Yeah.
Oh, it is password. Okay, never mind. I put it in there as essay because sometimes.
No, that's
never mind.
That's the user. The details are
Okay, cool.
here in application properties. If you need them. Obviously, don't expose this to the internet, please. Okay. For instructional use only. So anyway, where was I? I was looking at login HTML. Oh yeah, now I'm going to change the type of this field back to text because I want to be able to see the numbers as I type them in. I'm worried about making typos. It's a little bit annoying if I do. And actually, I don't think like shoulder surfing is a big problem because this passcode is only valid for 30 seconds. If I hear someone turn around and run off to their own computer, maybe that is a problem. And maybe you would decide differently if this was your website, but I'm okay with it being text here. Okay, and I'm going to change that, the actual wording of it, to 2FA code from your app. Right, that's it. So this name here, 2FA code, we can grab that out of the HTTP servlet request, which is used in custom authentication details. This would be a good place to pull any extra parameters that we might need to authenticate our user out of the HTTP servlet request. Store them in fields here and access them later on. Okay, so we're going to store them as a field. This could be a final string, couldn't it? Because it's the constructor that it's being set in. 2FA code, that's not valid Java, is it? So I'm going to have to call it something different. User 2FA code. That's fine. I mean, it's not valid Java because it's final and I'm not setting it in the constructor, but I will. So this dot use 2FA code is request dot gets parameter. And this is the string that has to match the name of the element in the form, 2FA code. And we'll need a getter for it. Yeah. So those are the changes to the custom authentication details class. This is constructed when a user tries to log in. And then we can intercept the actual kind of authentication mechanism in the authentication provider class. And you have access using this line of code here. You can call authentication that's passed in, .get details, cast it to a custom authentication details, and then you can get the 2FA code that the user's provided out of that object. If you want to prevent them from logging in, you can throw an authentication exception or a subclass of that. Bad credentials exception is a subclass of that. And if you're happy with the extra checks that you've done, you can then pass it to the super to do the regular authentication of checking that the username and password are correct. And Spring's taking care of the hashing of the password and that kind of thing. So we don't have to worry about that, which is nice because it's a little bit complicated. Fiddly, you know. Done. Yeah, okay. This code I know is actually quite a lot. I'll copy it all. Dolt, different capitalization. correct it here as well. And therefore here and here. So the first thing we can do when we're doing this authentication check is get the username that they're trying to log in and look up the user DTO in a user repository, which will fetch it from the database. We need a user repository. We can auto wire one, and that's up here. It just needs uncommenting. If the user DTO is null, we'll just skip all this and go to here, and that will presumably fail. Now we can generate a code on the server side because we know the user's secret from the database. We know the current time. This method was not deprecated in version 1.2. What's happened here? There's no explanation of why it's deprecated, which is a little bit frustrating. Random base these two. Perhaps I am supposed to simply pass in system.currentTime millis here myself. This method's not deprecated, and this one calls that one. So I'm going to keep using this deprecated one for now. But yeah, I guess I don't know why that's deprecated, but we could just avoid it by calling that ourselves. Anyway, the point is that it's not that difficult to change it, is it? Well, let's do it. The point is that we can generate a code on the server side using the secret, the current time, the fact that we want 6 digits, and the fact that we want a TOTP. So this is the same line of code from my demo in the middle of the talk. We can cast the authentication.get details as a custom authentication details. And from that, we can pull user 2FA code. So we've got a server code and we've got the client provided code, right? If they're the same, then that is a successful second factor. I changed the version in the POM to 1.3. If you're still using 1.2, it won't be deprecated. Yeah. OTP.time in hex has been recently deprecated. But don't worry about it. Just use time in hex. I believe this overload existed in the previous version as well, so you can pass that in, or you can just call it. If it's not deprecated, keep using it. It doesn't seem to be any different in terms of the implementation. So, yeah. So I said if these two aren't the same, then we can fail the login. Well, I said that if they are the same, we can succeed, but it's the same. So we'll just use string.equals. I suppose it's possible that this will throw a null pointer exception if the server generated code is null, but we'll assume that OTP doesn't do that. If they're different anyway, if they're not the same, then throw a bad credentials exception. This will prevent user login. We'll get a stack trace. Might want to do something better about logging. Might not want raw stack traces appearing out here, but you can see as you read the code further that my approach to error handling in this is not production ready. We'll catch any kind of exception here. OTP.create can throw exceptions. It can throw illegal argument exception, invalid key exception, and Java security no such algorithm exception. I've never seen it throw any of those, but it might. And we can catch anything that happens and just say, look, if we can't generate a code on the server side to check whether the client has matched, then really we can't say that that's definitely the person is definitely who they are representing themselves to be. So we can't log them in. It's our problem. It's probably like an error 500, but we still can't actually just throw our hands up and go, okay, fine, come So we throw an exception here, authentication service exception, just failed to generate the server-side code. If we get through all this check, we just fall out the bottom of this if and go back to username and password authentication. Oh, was that the last thing? I've forgotten already. Yes, it was. Check that the code provided by the user matches the code we generated on the server. So if you're following along, let me know if you've made it this far. Happy to bounce the server. Bring up my phone here and delete this one because I don't need it anymore. Goodbye. Okay, and go and log in. And let's see if it works. Of course it's going to work. Everything works first time in demos, doesn't it? It's fine. So, register. Matthew. Password. Create account. Add account. Use that QR code. Save. Log in. And I'm going to do a little bit of test fuzzing here. Hey, you're with me, Justin. Cool, thanks. Matthew, password is password. And, oh, I fat-fingered that one. I'm going to type in the 2FA code from my app, but I'm going to type it in wrong. Log in. No, you can't log in. And you see down here, we get that bad credentials exception logged down here. Let me just move my phone out of the way. Server code was that, user code was that. Oh no, yeah, all of that stuff. Oh shoot, there's actually, sorry, that's just noticed, that's a bit weird, isn't it? This bad credentials exception could be thrown all the way out the top, but it's not, it's being caught here and it's not even being wrapped. This is terrible, but it achieves the effect. So I'm sorry about that. Okay, let's go back to trying to log in, get away from my error handling. Matthew, password. Wait, that wasn't it. Thank you for the sympathy from Casey, Joe. We've all been there. So, yeah, we can see that the bar is not going to hit the bottom. At least it's being logged. Yeah, absolutely. 752. I'll get that out of Elasticsearch later. Log in. Hey, look, that worked. And we can see, let me just move my phone out of the way again. Server code that, user code that, matched, right? We can even try like to log in just as the number changes and see what happens. So at the moment it's 43955. God, typing, eh? Okay, so I'm just gonna like see. No, instantly. Okay, so if I wanted to allow that situation to log in, the place to add it would be here. I could generate two server generated codes using system current time millis and system current time millis minus 30,000 for 30 seconds, and then check them both. I'm generally happy with rejecting that login rather than doubling the kind of possibility of a brute force attack working. And I suppose that's what I would recommend. So I'm going to pause there. Thank you, everyone who's been talking in the chat and everyone who's been following along without talking. If it's okay with you, Billy, I'm going to ask, do we have time to go and add the have I been pwned bit, or would you want to wrap up?
Let's see. I guess let's see what people in the chat think. Do people want to check out the pwned API, or is everyone?
It's kind of interesting how it works. I'll tease it like that, but you know, if people are leaving, I appreciate we've been running for an hour and a half already. So
yeah, I think we may want to wrap at this point. Unfortunately, I think most people are probably going to get ready to do dinner now. So.
Hey man, I'm fine with that. It's 10 to midnight here.
Yeah, I know. I'm sure you're probably ready to go to bed.
I'm fine. No, I'm not ready to go to bed. I've got a beer waiting for me.
Okay. Oh, nice. So, no, but yeah, that was great. I didn't do the Have I Been Pwned edition to it, but I got through the first two parts, and yeah, it was pretty quick and easy. I mean, granted, it was just copying code, but I kind of view it as like if you want to get two-factor authentication going, or at least some parts of it going. Yeah. It's not like, okay, you have to do these 85 steps.
No, not at all, right? I mean, I will say that repo took me a while to put together because of just having to troll through all the Spring documentation to find out where to put those points. So if you find it useful, obviously, like we saw, there are some terrible non-production ready bits of code in there, but generally, like the approach is all right. Yeah, the Have I Been Pwned API, it's all in this tag. You can just read this extra credit page for that if you want to work on that. Feel free to get in touch.
But for anyone still here, I posted the Java News slide deck and the workshop link into the meetup, and I also updated the description of this YouTube video with both as well. So yeah, hopefully if anyone else shows up on this later, usually we get a good amount more people later on. Most of our videos get over 100 views, so there'll probably be some more people showing up later on to check this out as well. So
cool.
Yeah, thanks you again so much, Matt, for coming and sharing this with us. This was a really great presentation, and also it's always great to have a workshop with it as well. Yeah, well, thanks for inviting me over, and good luck in the new job. And thank you. Yeah, take care, and fingers crossed for returning to like in-person events. Definitely. All right. See you, everyone.